Hello, my name is Nick Hallenstein. I'm a Microsoft Integration MVP as well as Visual Studio ALM Ranger, and I work as a Principal Software Development Engineer for Quick Learn Training. I'm here to welcome you to this talk, Processing NFC Tag Reads in a Logic App. Now in this talk, we're going to show how we can take device signals like NFC tag reads and use those to trigger logic in the cloud that can be used to integrate with, in this case, CRM systems like Salesforce and Sugar CRM. Now within the overall Azure platform, the tools that we're going to be focusing on are logic apps and API apps, so those live in the web and mobile space. We're also going to be doing the work of integration, and so we've highlighted those parts of the platform here. Now this is only a small slice of the overall Azure platform. But let's go ahead and take a step back and start with a story for why we're doing what we're doing, kind of set this stage. Let's pretend that we're actually at a regular tech conference where we're able to walk around the exhibition floor and see all the wonderful different products that are there for us to experience, all the different companies that are there to offer us things. And during the conference, that typical experience would have us maybe walking up to one of those booths. Maybe we're standing behind the booths waiting for customers because we have something that can change their lives. And so attendees are going to approach the booth. They're going to look for swag. They're going to take that swag. It's going to be great. Eventually, they make eye contact. And this is our moment. This is our moment to say, hey, can I scan your badge so that you can win something awesome? Or can I scan your badge so that we can sell you something later and give you some wonderful life-changing stuff? So we scan the badge. We reach out and we get this conference badge. We scan it with some device. And maybe that's a barcode. Maybe that's a QR code. Maybe it's an NFC tag read, but it looks really slick. But the reality of it is after the conference, the experience isn't quite as slick. Because eventually we do need to take that data from your conference badge and turn that into a lead within a CRM system so that we can contact you about the wonderful stuff that you were so excited about at the conference. So what it looks like after the conference typically is data is retrieved from that device that we scanned it on, maybe in a CSV format or something maybe even more barbaric than that. From there, it's going to be maybe emailed around a little bit. Eventually someone downloads it to their machine, goes to the website for our CRM system, and uploads it. But as we look at that, we can say that's a lot of ceremony over just a few bytes of data. And in fact, that's a little bit out of line. There has to be a better way. There has to be something different. Now, a few years back, a man by the name of James Whitaker, over at the ALM Summit 3 in Redmond, right here, proposed that there's actually 3 eras of compute that we've experienced, and right now we're living in the know and do era. Up until the early 90s, the era of computing we were in was store and compute, which was centered around applications and processing files. That gave rise to search and browse, where in the early 2000s, we were about building web pages and searching for data through search engines. And now we're in an era that's built around not applications or web pages, but about experiences. People don't care to focus on one device. They want their stuff everywhere. So what is the thing that we build in the know and do era if we're building experiences? Well, I'd propose that the stuff that we build is logic that lives in the cloud that's accessible from all the devices that are out there. And in this case, we're going to be looking at logic apps as an enabler of experiences. So what is a logic app anyway? Well, a logic app is something that can connect signals, sensors, devices, and apps because it's a workflow that's hosted in the cloud. Now that workflow has a series of steps which we can actually get from the Azure Marketplace. And we can see a nice little screenshot of that there on the right. We see connectors like SharePoint, connectors like Twitter. We have social signals. We have signals from maybe our internal business systems. And in fact, if we're looking at that list and we're saying that's not enough, we can always create our own. So stepping back to our story of a conference where we want to be able to take these badge scans and turn those into leads in CRM, how can we do that in a logic app enabled world? Well, maybe that tag read is actually a signal that triggers a logic app. So the typical flow still happens. Attendees are still approaching the booth. They're still getting the swag, making eye contact. We're still scanning the badge, but that's going to trigger some logic in the cloud. At that point, that logic app can take that data further and get it directly to our CRM system without all the ceremony. So how do we build this? Because ultimately at the end of this talk, we're going to have built every piece necessary to make this possible. So how does the data get from the device that scans the tag to the logic app as it becomes available. Well, we're still going to have an app in play. We're going to still have a place where we're receiving that signal and doing something with it. But what that's going to be doing is it's going to be triggering the logic app by calling it back somehow. And you can say, well, but wait, didn't the problem start as how were we supposed to call it in the first place? Yes, it did. So really, the logic app has to tell us where it lives. The logic app has to say, I'm interested in tag reads. Here's where I live. Here's how you can contact me. And the mechanism by which it does that is a push trigger. In this case, an API app. So it looks like a website project. Now that API app is going to have an API that allows an HTTP put request to be sent to it from a logic app that says, I'm interested in tag reads. In this case, that request is going to contain a URL with credentials necessary to call back to that logic app when we actually have that data available. Now, it's the key responsibility of that push trigger API app to store that callback information, the URL, with the credentials in some sort of storage mechanism. From there, anytime we actually have an event within our application, so a tag is read or something like that, we can retrieve that data from the callback store about where to call back the logic app, and we can send a request to say we have the data. In the case of this presentation, our push trigger API app is going to be built as an API app project. So we have that as a project template in Visual Studio. Our callback storage is going to take advantage of Azure App Service mobile apps because those give us a nice backend for mobile apps that work across different devices. And as far as our NFC tag read app, we're actually going to implement that as a universal Windows application so that I don't have to care what device I have with me. I can still do a tag read from it. So over in Visual Studio, I have a solution with 3 different solution folders. One of those is titled Azure, one of those is Device, and the last one there is Shared. Now that reflects where this code is actually running. You'll notice in the Azure folder, I have an API app project called NFC Push Trigger. Under my Device folder, I have a universal Windows application called NFC Client App that could run both on my laptop as well as my phone. And then finally, I have some shared data models that are the shape of data that's going to be exchanged between. So let's go ahead and start with our NFC Client App that's going to be doing the actual tag read. Now within the actual client app here, I have basically the beginnings of the application that you might see if you create a new project. So there's no code there that's doing anything yet, but I do have a wonderful UI. And that UI basically is just the text scan NFC tags. So remember, there's nothing really exciting going on in the UI here. All the magic is happening in the cloud. So even on the device, we're not going to be writing the smarts to talk to our CRM systems. We're going to be writing the smarts to read a tag and trigger a logic app. All right, so what does that look like? Well, first of all, in order to use NFC capabilities, we need to go into the package manifest on the capabilities tab and declare that we're going to be using the proximity sensor. So one of the first things that we'll need to do is make sure that we're using the proximity sensor. From there, within the code, we can start writing code to get access to the current NFC reader. So I can say NFC reader equals proximity device dot get default, and that lives in the Windows networking proximity device, or proximity rather, namespace. From there, I can say to the NFC reader that I'm interested in messages of certain types. In this case, I'm interested in messages that are stored on NFC tags that are formatted using the indef format. So for these conference badges, I have an indef message that has a vCard or virtual business card record as the first record. And we can parse out of that the name of the conference attendee, their email address, and other contact information. From there, I do need to provide a way to kind of handle that event. And so the way I do that is not necessarily by wiring up an event handler here, but instead providing a callback. So I'm going to get in an instance of the reader, the message itself, and I'm going to throw that into some logic. Eventually, I'm going to be doing some async goodness there, so I'm going to go ahead and put async in front of that lambda so that I'm able to do that. Of course, because I'm not yet doing anything async, Visual Studio will be very happy to underline that green for me. Now within this, I'm going to go ahead and grab the raw tag data from the tag read that came in. So it comes in as a message. I'm going to go into the data, which comes in as an iBuffer, and I'm going to take that to a byte array. From there, I want to go ahead and get the current tag read in a more human readable format. So I'm going to go ahead and say that I want to go and use maybe the ASCII encoding and get that as a string. So I'm going to go in and get the raw tag data as a string. And later, I'm going to be sending it to a logic app. And my logic app is going to want it as not necessarily a byte array, not as a human readable string, but maybe as a base 64 string, so that we can later parse that out in a step within that logic app. So I'm going to have my tag data as base 64 as well, using the convert.to base 64 string method. All right, so I'm going to pass my tag data in a few different ways. Now, as I'm scanning the tag, maybe I have a shaky hand, and maybe I make contact with the reader, lose contact, make contact again. I don't want to send that same signal multiple times. My logic app doesn't need to hear about my shaky hand. So as a result, I'm going to keep track not only of the current tag read, but also the last tag read. So I'm going to add a string property for my last tag read so that I know what the tag was that was last read. And I'm going to go ahead and say that the last tag read was whatever the current read is right now. Now in between, I'm going to do a check to see if essentially the last one is the one that just happened. So is it a duplicate? So I'm going to say I want to have a variable called isDuplicate that basically is equivalent to the idea that the current tag read equals the last one. So if the current tag read is the same as the last tag read, then we're dealing with a duplicate message. Now that should be enough code to get us in a position where we can actually start to scan some tags and see some results out of this. So I'm going to go ahead and set a breakpoint here on this last line. I'm going to right-click the project, and I'm going to deploy that to my device, in this case, my laptop. All right, so at this point, I have that code deployed, and I'm going to go ahead and start debugging. So I'll right-click, I'll say debug, start new instance, and that'll launch on my laptop. I have the prompt to scan NFC tags, and so I will. And I've actually brought a few along. So one of those is actually a conference badge from a conference I recently spoke at. It has my, my name and my company and all that fun stuff on one side of it. And on the other side, it has my QR code that represents who I am. It has an NFC tag that represents who I am. And even if you wanted to cross-reference with some sort of printed out spreadsheet, it has my ID. All right, so I'm going to take this and I'm going to put it against my USB tag reader. And we'll see that it hits that breakpoint because it received the tag read. And we'll be able to interrogate what that current tag read is. And in this case, as I open it up as kind of text, we'll see that it is me. So we can see my first name, or my full name rather, is Nick Howenstein, and we have my email address, nh@example.org, obviously not a real email address there. All right, so we are getting the tag read data. We know that it's not a duplicate at this time. If I run this again, and I do that same tag read again, and I scan that one more time, we'll see that this second time around, it happens to be a duplicate. It's the second time that we've actually seen that same tag. All right, so we have a good start in the form of an application that can get a signal about an NFC tag. However, what we don't have is we don't have that data going anywhere yet. And ultimately, to get it into a logic app, and let me go ahead and dismiss this window here. To get it into a logic app, we need to have some sort of mechanism, some sort of step that we can add to the beginning that triggers the flow. And in this case, that's going to be an API app that serves as a push trigger. So I have a project here that is very much just kind of the default starting place that you get for any kind of web API that's going to serve as the bit of code that's going to allow the logic app to say, here's how to call me. Here's where I live. Here's the credentials you need. Once you have data that I'm interested in, go ahead and call me back. So I'm going to go into this default values controller. I'm going to rename it because ultimately we're not dealing in values, that generic concept that's built into the project template. We're dealing in callbacks. So I'm going to go ahead and say that this is actually my callbacks controller. Now within my callbacks controller, I'm going to delete all this default stuff that I'm given except for maybe the put operation. In fact, I'm going to give that a prettier name. So register callback is what we're trying to do. And I'm going to use attribute routing to give it maybe a prettier address as well. So maybe instead of put API values 5, that looks crazy, it's going to be something like callbacks, some sort of ID for the callback, in this case, maybe the name of the logic app. And I want it to look like that. So I'm going to put a route prefix on the overall controller of callbacks to satisfy the first part of that URL. In this particular method, register callback, I want to have that accessible through an HTTP put request, and I want that to be at the route of trigger ID. Now, because we're kind of using that as a parameter, we got to make sure that that's actually a parameter of the message that can be parsed out, or of the method rather. So I'm going to go ahead and say that we're going to go ahead and take in that string trigger ID. Now that's great, but that's just the name of some logic app or the name of some trigger. Where's the actual callback? Where's the actual address that I'm using to call back to it and do great things? Well, actually, we have to start using some special classes that are built into the Azure App Service SDK. Specifically in this case, there's going to be a parameter that gets passed in from the logic app called the trigger input. Now, the trigger input, again, is part of the Azure App Service SDK. You can kind of see what namespace that's going to try to add. And it's a generic class that allows us to specify both the shape of the configuration for our trigger. So in the case of our tag reads, maybe we want to be able to configure if we're going to suppress duplicates or maybe we allow duplicates. Because maybe I want to see every last tag read versus those that have been deduplicated. So maybe we have some sort of configuration around it. So I actually have a data model for what our configuration might look like, and it's empty right now. I'm going to go ahead and reference that class, though. I'm going to say that, yeah, we'll go ahead and say we need a push trigger configuration passed in, and we'll define the shape of that. So let's go to that. Let's define the shape of that. And for our push trigger configuration, I'm going to say that there's really only going to be one option, and that is a Boolean value of whether or not we're going to suppress duplicates. Now, because this is going to be surfaced within a logic app, so I'm going to be able to click in the logic app designer, add a little card to the start of a process and say, yes, I want to suppress duplicate tag reads or not. I'm going to want to have this look really nice and friendly there. And so there's a NuGet package called T-Rex that gives me attributes that I can add, like metadata, to those things that are going to be shown in logic apps so that I can provide friendly names and descriptions for those members. So I'm going to use T-Rex metadata here to add a nice friendly name for that property. All right, so back in the callbacks controller, and let me go ahead and close those other windows there. We have the push trigger configuration coming in, and then we also have to declare what the shape of the output is for this trigger. So once this trigger actually has data available, what is that data going to look like? Well, we've kind of already said that we're going to be sending some base 64 encoded data. So I'm going to go ahead and contain that within a class called pushTriggerOutput. So my pushTriggerOutput class right now doesn't have any members, but I do want to have one called tagReadB64 or something like that. And again, a nice friendly name around that, using the metadata attribute of maybe base64 NFC tag read. It's kind of a more verbose name, but we'll go with it. All right, so that's maybe the shape of our output for our push trigger. And at this point, we're almost in a good place. We do have to name this parameter. I'm going to call that parameters. Those are the parameters that the logic app is going to be passing in. And there's actually two responsibilities that we have as this push trigger. We're going to be passed in this really important information. So we need to store the callback. We need to store that really important information. And we need to report that everything is happy. We need to say that, yes, we did store the callback. I'm going to start with that last part because it's really easy. There's one line of boilerplate code that you're going to be writing every single time you need to do this. And it's going to be using an extension method called pushTriggerRegistered on the request object. Now, that's part of the App Service SDK. And it's going to be wanting you to pass in a value from that parameters object. So it's ping-ponging it back. It's giving it to you. You're handing it back to say, yes, I got the message. And you're going to say parameters.getCallback. So it's just a method there and a little bit of boilerplate. Unfortunately, it's not happy because I'm actually returning void at the moment. So I need to make sure that I'm returning some sort of HTTP response message. Now, I know you'd love me to make that an iHTTP action result, and that would be great. Unfortunately, I don't want to wrap that around with a method to create that, nor does the actual extension method generate one of those for me. Finally, I do intend to do some async work as well. So I'm going to go ahead and just say it's actually going to be a task of HTTP response message. So that's great. All right, so we do have to do the work of storing the callback. So how are we going to store the callback? Well, we said before that we're going to take advantage of the full Azure platform in the sense of using an Azure App Service mobile app here. So rather than write all the code to interact with a mobile app, I actually have included that already as part of this project. So I'm going to go ahead and bring that in. And you'll see that we have maybe a data access class that has code to write a callback, given a trigger ID or the name of the logic app, given a callback URI, and given the configuration, we have code to save all that. Now this is all implementing a nice standardized interface called iCallbackStore, and that's part of the quicklearn.logicapps.pushtrigger NuGet package if you want to have a copy of that interface. That provides us a nice standardized way to save our callbacks. So what this is doing is it's looking up to see if we already have a callback for that specific logic app registered. So it's looking up by trigger ID. If we do, then we update it. Otherwise, we create it. All right, so pretty straightforward code there. So what I'm going to do is I'm going to use that. So I'm going to say I have a callback store that implements this lovely interface. Of course, I have to add a using directive for the appropriate namespace as a result of that. And I want that to be, in this case, an instance of our Azure mobile app callback store. All right, so at that point, we have the callback store, but we haven't actually used it to store the callback. So I'm going to say callback store.write callback async. And of course, because that's an async method, we're going to want to await that. And I'm going to pass in the trigger ID that was given to me. I'm going to pass in the callback URI that was given to me. Now you can say, well, where was that given? Because I only have trigger ID and parameters. Well, it's actually under parameters. It's not a part of the inputs, which is actually my push trigger configuration, but it's part of the object returned when I call that get callback method. So I'll be able to see the callback URI, and that actually has embedded credentials in it to invoke the logic app as well. So I'm going to go ahead and pass that for storage. I'm also going to store the configuration, which is part of parameters.inputs. All right, so we're storing the callback, we're reporting that everything is happy, and this is great and this could work. However, there's one more thing I'm going to do. So just like we made our inputs look really pretty, right now if I was to try to use this in a logic app, it would look like callbacks controller underscore register callback, and it wouldn't really be clear as to what this trigger actually is about. And what this is about is an NFC tag read. So I want to make sure there's metadata here to say that this is actually a trigger for whenever an NFC tag has been read. And further, there's a trigger attribute provided again through T-Rex that allows me to say this is actually a push trigger as opposed to a polling trigger, and the shape of the output is push trigger output. So pretty nice for us there. All right, so that's good enough to get started. I'm going to go ahead and run this locally just to test that we have the ability to see that operation there appropriately and that it actually works. All right, so that's going to start up at basically the root URL, which is forbidden. But we're going to go out to swagger/UI/index because one of the things that's enabled here is Swagger UI, which can read metadata from our API app and show us all the operations that are available. So you can see we have this NFC tag read operation, so that's how it's going to show up in the logic app, and that's going to take in a trigger ID and our parameters, and we can see the shape of that includes the ability to suppress duplicates, and when we return stuff from this, it's going to look like our tag read base64 string. So that's great. So with that, it's ready to deploy to Azure. So I'm going to go ahead and take that, and I'm going to deploy that to Azure so that it's available, after I stop debugging here, so that it's available for use within a logic app. So I'm going to right click, I'm going to say publish. Now I've already downloaded the publish profile for my API app container that I pre-provisioned. So I'm going to go ahead and deploy that with debug, configuration, remove any stuff that's already out there, do some pre-compilation so that it runs a little bit faster on the first request, and I will publish that. All right, so once it's published, it's going to open up a browser window, this time pointing to its location up in Azure. All right, so nice valid metadata is available. I'm going to go ahead and close that and kind of get back to things over on the device side. Because at this point, we have something out in Azure that can get information from a logic app about where to call it back when we have data. So there's a logic app now that could add that step and say, I'm really interested in tag reads. And we can say, great, let's go ahead and write down your information so that we can send you those tag reads as they become available. Now we do have to add some code to the device side of things to do something with that. So within the device code, rather than just going and looking at the information locally, I want to send that to the cloud. I need to look up the callbacks though to do that. So the way I'm going to do that is pretty similar to what I had done before. So I have some code here within this data access folder that uses an Azure mobile app, again, against a nice standardized interface for storing those callbacks, that has a method called read callbacks async. And it's going to go get the table of callbacks. It's going to get all the callbacks that are there and then project those into the shape of our configuration plus the raw URI. Now you can see it's creating a new instance of this callback class. Now that callback class is part of a NuGet package called quicklearn.logicapps.pushClient, which gives us a one line of code way to invoke a callback once it's read from the store. All right, so I'm going to add some code to get all the callbacks that are in the store. And it might be a good idea to cache this, not make this request every single tag read, but in this case, I am going to be doing that. And of course, I do need the callback store created. So let me actually new up the callback store before I go too far there. Azure mobile app callback store. All right. So I'm going to say callback store.read. Oh, you know what? I'm missing one more using directive there for the interface itself. There we go. So callback store.read callbacks async. And that's enough to go out and read all the callbacks. Now from there, I'm going to look through each callback in all those callbacks. And I'm going to say if that callback configuration, because we can dot into that configuration nice and strongly typed, it gets to our model of what that configuration looks like. If that's trying to suppress duplicates and the current tag read is a duplicate, we're actually going to continue on to the next callback. So maybe I have a few different logic apps that want to be notified whenever a tag is read. If not, so if we're not dealing with a duplicate or maybe it's not configured to care, we're going to go ahead and say that we want to invoke that callback. Now, as we invoke it, we're going to pass it some data. In this case, our push trigger output, which is going to contain the tag read data as base64 encoded text, which we've stored locally as tag data b64. All right, so I'm going to go ahead and move my breakpoint down to here. I'm going to fix that, that expression right there. And I am also going to await that call because that would be a great idea given that that's an async method invocation. All right, so I'm going to go ahead and set my breakpoint. I'm going to deploy this locally to my laptop. And then I'm going to switch gears. And I'm also going to deploy it to my device. So I actually have my Windows Mobile phone that's running Windows Mobile 10 or Windows 10 proper. And it's basically a Nokia 920, so it has an NFC reader on the back in this little silver strip. So I'll be able to read an NFC tag against that as well. So I'm going to do a deploy not only to my laptop, but to this device. So I'm going to go ahead and plug this in and get all logged in on my phone, so it's happy to do that deployment. You do have to be authenticated to do that deployment. I want to go to my ARM-enabled device, and I'm going to say deploy there. All right, so the deploy succeeded to my device, so I should have that same exact application, same exact code now running on my device. So I'm going to go ahead and start that up on my phone, and not sure if you can see that at all, but we can see the exact same scan NFC tags is running there. All right, so I'm going to go ahead and set this aside, and let's see what happens as we begin to use this. So right now, if we began to use this, actually, it would do nothing. It would still just scan the tag and show it to us locally because there's no logic app that's really excited to receive NFC tag reads. All right, so let's go over to the Azure portal and take a look at a logic app out there that basically has a few steps in it already, but it doesn't get triggered by anything. So I have to log in here with my Microsoft account, so I'm going to do that very quickly. And here on my start board, you can see that we have this NFC lead import logic app. That NFC lead import logic app has basically 3 actions already, but no triggers, sadly. Now, as we look at that, those 3 actions are to first parse the data from the tag read. So we get an indef message in as a base 64 value that's going to be passed from our app, but we need to parse out that data so that we get the vCard information out of it. Now this step, this indef parser step, shows up in my list of API apps, but it's actually not part of the Azure Marketplace. Instead, you'll find that that's actually a sample API app that's available over on GitHub at this address right here. If we scroll down, we can see that we can deploy that with one click out to your Azure environment so that you have access to using that within your logic apps if you wish. And we can see that that's going to give us a first name, a last name, and email address out of that mystical base 64 encoded string. So that's awesome. All right, so that's our first step. Now the last 2 steps are actually built-in connectors. One of those is the Sugar CRM connector, which is going to be passed in some data from that indef parser, in this case our given name and last name, to use to create a lead. And then finally, we have our Salesforce connector, which is going to be going out and creating a lead, again with that information. So what triggers this flow is a tag read, except that right now the flow doesn't know that. The logic app doesn't have a card right here to say what actually starts the logic. So in this case, I'm going to go ahead and click our NFC push trigger that we just deployed. Once I click that, the designer doesn't really know what we're going to do with it yet, so it says, okay, that's probably going to be the last thing we do. And so I'm going to say, no. This is what actually triggers the flow. It's going to be triggered by a tag read. And when it comes to that tag read, there's going to be configuration around it. In this case, whether or not we suppress duplicates. So I'll say, yeah, we do want to suppress duplicates. So I'm going to go ahead and click the check mark for that. And at that point, it should know that that triggers our flow, and it'll rearrange the order of the steps accordingly. Now, in order for us to make use of the data that's coming in here, I actually have to update what's feeding into our indef parser. Right now, it just says to do. That's something I need to do. So I'm going to go ahead and edit that action so that it uses the data from the trigger. Now I could go in and click on the little ellipsis there and get access directly to this, but I actually want to type this by hand so you can kind of see what it would look like to write this expression and understand what's going on. So first of all, this base 64 NFC tag read is actually just that tag read B64 property in disguise. So I'm going to get from the trigger that data. Now to do that, I'm going to use the Logic Apps workflow definition language and use some of the functions that are available as part of that, like triggers, to be able to get at the trigger output body. And within the body, I have that tag read B64 property. All right, so any kind of @ sign says don't interpret what follows as a literal, interpret it as an expression, in this case built-in function, and then dotting into the outputs of this trigger and getting into the tag read B64. All right, so that's great. I'm going to go ahead and click the check mark there. And I'm going to click Save in the Logic app to save all these changes. All right, at that point, as we go out to look at the overall blade here for the NFC lead import, we have one trigger and 3 actions. So we can see that our trigger is in place and it's ready to go. So let's see what happens now as we go over to Visual Studio and we launch the application and scan a tag again. So as I launch the application, we see the Scan NFC Tag Reads UI show up. I'm going to take my trusty conference badge and I'm going to go ahead and scan that on my tag reader. And we'll see that it's going to hit that breakpoint that we had set before it invokes the callback. So we can investigate the configuration. We do want to suppress duplicates. This happens to not be a duplicate tag read, so we're good to invoke that callback. Now at this point, magic has happened in the cloud. That logic app has received that data, it's parsed that data, it's talked to Sugar CRM, it's talked to Salesforce, and we'll have a lead named Nick Howenstein, basically the name that was on this badge. Now I could just say that and walk away, but it doesn't really mean anything until you see it, right? I could be lying. So definitely not lying. Let's take a look. So I'm going to go out to Sugar CRM, and I do have to log in. It's been a while since I've been there. And I'm going to go over to Salesforce as well. And again, log into Salesforce. And we'll see that both in Sugar CRM, if I search for a lead with my name, I'll have a lead named Nick Howenstein. And in Salesforce, if I search for a lead with my name, I'll have a lead named Nick Howenstein. All right, so the data has made it into both places. They might say, well, that data was already there, that doesn't count. Well, in reality, if we look at the logic app, we can see that it actually just ran. And we can see that all those steps succeeded, that it really did talk to all those services. Further, we said earlier that we can deploy the same code on a device. So I have my Windows phone here, which is running Windows 10, and we actually did a deployment of the application already. So I have the application now running on there. Scan NFC tags is what it says. And I have one more conference badge. And this conference badge actually has Scott Guthrie's contact information on it. He's famous for his red polo, so I imagine if he was going in disguise at a conference, maybe wearing something a little bit less formal, he might be wearing something like this. All right, so I'm going to take this tag, and I'm actually going to scan it on my phone. You can kind of hear that it has made contact with the reader there, and that should trigger the flow again for Scott Guthrie. Now, as it triggers that flow, we're going to be able to see in both Salesforce again and Sugar CRM that it happened. I'm actually only going to check in one of those. I'm going to go over to Salesforce. I'm going to refresh, and we should see that not only do we have a lead for myself, but we also have a Scott Guthrie lead that's just shown up. All right, within the Logic app, if I were to refresh this page, we could go in and see the Logic app runs that have happened. So I'm going to go ahead and click on that and see the success. Of course, that says 2 minutes ago, so let me refresh one more time. So we'll refresh this page. And we'll see that we have 2 successful runs of that process. So where do we go from here? This is a pretty sweet application, but maybe we enrich this data using other signals we have. Maybe we know it's a conference. We know that it's at some location because our device has GPS. It has, we know what date and time it is. We know what people's calendars look like potentially. So maybe we could enrich that data and say, this lead came from this conference. Maybe we enrich the data with data from other systems. So we look up the revenue of the company that the person worked at. Or maybe we know that they've come into our system before. They've been at conferences all the time. They're scanning the badge. Maybe we just know, hey, they're here for the swag. Good for them. Let's give them free stuff and let's not bother them. Maybe kind of disqualify them as a lead. Maybe we use this to start long-running processes that live in the cloud. Maybe a drip campaign, some sort of marketing work, kind of that goes out over a long period of time and sends emails. Maybe we enable rule-based processing using one of the BizTalk API apps to basically make a decision about how we handle this particular tag read. Now, maybe you're looking at this and saying, well, wait a minute, I don't care about sales leads or conference badges or any of this. Well, remember that this can be generalized. NFC is used everywhere. It's in our transit passes, it's in our room keys as we go to hotels, it's in our loyalty cards, it's in our payment cards. People even use it for authentication. I have one built into my ring that I use to get into my door at home. Maybe you're looking at that and saying, well, I don't care about NFC. But I do like the idea of building experiences that transcend devices and have the logic in the cloud. How can I trigger those? Maybe we look at social triggers. Someone has tweeted something unhappy about my company. I want to respond to that in a meaningful way. Maybe we have a logistics company. I want to have a geofence trigger whenever a delivery vehicle reaches a certain location relative to its destination. Trigger some process in the cloud. Maybe I have sensor triggers. Maybe I have a radiation sensor. If radiation levels get too high, we take some action. Or maybe there's something more, just kind of regular businessy stuff with databases and files, and I want to trigger a process in the cloud based on those. You can generalize this solution and let it be what you need it to be. I have some resources here on this last slide. that you can take a look at. Full source code for this demo, everything that we saw is available at that first link. The second link there is for the Logic Apps documentation as a whole. So if you want to get deeper into Logic Apps. Along the way, we used the T-Rex metadata library. We actually used an in-depth library within the sample API app to parse out the data. So I did want to give some mention to those. And then finally, the concept of this new era of computing was proposed in another talk that's worth a watch. And so that link is there at the bottom. So I want to thank you for watching this talk, and I want you to go build great things.